Download this code from codegive.com, link in the description below. OK, let's dive deep into creating an ESP32 WebSocket server using the Arduino IDE and JSON for communication. This tutorial will be comprehensive, covering everything from setup to more advanced features like handling multiple clients. Understanding the concepts. Before we begin, let's establish a clear understanding of the key components. ESP32 a low-cost, low-power system on a chip, SoC, series with Wi-Fi and Bluetooth capabilities. We'll be leveraging its Wi-Fi to create a network and serve our WebSocket. WebSocket a communication protocol that provides full-duplex, bidirectional, communication channels over a single TCP connection. This means the server and client can send data to each other simultaneously, making it ideal for real-time applications. It's more efficient than constantly sending HTTP requests, like polling. Arduino IDE a cross-platform application that allows you to write and upload code to ESP32 and other microcontrollers. While the core is Arduino, we will use ESP32 specific libraries. JSON, JavaScript object notation, a lightweight data interchange format that's easy for humans to read and write and easy for machines to parse and generate. We'll use JSON to structure the data we send and receive over the WebSocket connection. This allows us to send complex data like sensor readings, commands, and status updates. Server the ESP32 will act as the WebSocket server, listening for incoming client connections and handling data exchange. Client this could be a web browser, a mobile app, or another device that connects to the ESP32 server via the WebSocket protocol. Prerequisites. 1. ESP32 development board. You'll need an ESP32 development board, example ESP32 DevKit v1. 2. Arduino IDE. Download and install the Arduino IDE from the official website, https://www.arduino.cc/n/software, https://www.arduino.cc/n/software. 3. ESP32 board support in Arduino IDE ****. Open the Arduino IDE. *** Go to File-Preferences. *** In the Additional Boards Manager URLs field, enter. ** Click OK. ** Go to Tools Dashboards Manager. ** Search for ESP32 and install the ESP32 by Esp32 Systems package. For libraries * you'll need to install the following libraries using the Arduino IDE's Library Manager. Wi-Fi usually included in the ESP32 board support package, but ensure it's present. Wi-Fi client secure included in the ESP32 board support package. Arduino JSON this is essential for handling JSON. Search for Arduino JSON by Benoit Blanchon and install the latest stable version. Crucially important for compatibility. WebSockets search for WebSockets by Marcus Sattler and install it. Setting up the ESP32 WebSocket server code. Here's the code for the ESP32 WebSocket server. I'll break it down into sections with explanations. Code breakdown. 1. Includes include necessary libraries, Wi-Fi.h, WebServer.h, WebSocketServer.h, and Arduino JSON.h. WebServer.h isn't used directly for WebSockets but can be included if you want to serve a simple HTML page. 2 Wi-Fi credentials * replace your _Wi-Fi _SSID and your _Wi-Fi password with your actual Wi-Fi network credentials. 3 WebSocket server setup * const int port equals 81, defines the port number for the WebSocket server. You can use any available port. 81 is commonly used. WebSocket server WebSocket equals WebSocket server, port, creates an instance of the WebSocket server class, listening on the specified port. 4 Sensor data struct * defines a simple structure to hold example sensor data, temperature and humidity. You'll adapt this to your actual sensor readings. 5 Function prototypes * declares the functions we'll use for handling WebSocket events, sending sensor data, handling incoming messages, and constructing JSON. 6 Setup, function **** serial.begin, 115,200, initializes serial communication for debugging. **Wi-Fi.begin, SSID, password, connects to the specified Wi-Fi network. The while loop waits until the ESP32 successfully connects to Wi-Fi. WebSocket.begin, starts the WebSocket server. WebSocket.onEvent, WebSocket event, registers the WebSocket event function as the callback function for WebSocket events. This is crucial. This function is called whenever a WebSocket event occurs, client connects, sends data, disconnects, etc. * initializes the sensor readings. 7 Loop, function ***. WebSocket.loop, very important, this function must be called repeatedly in the loop, function to process incoming WebSocket events, data, connections, disconnect ions, etc. If you don't call WebSocket.loop, your WebSocket server won't work. * simulates sensor data updates. Replace this with your actual sensor reading code. *send sensor data, calls the send sensor data function every 5 seconds to send the updated sensor data to all connected clients. *delay, 10, adds a small delay to prevent the ESP32 from running at 100% CPU usage. 8 WebSocket event, function ***. This is the heart of the WebSocket server. It's called whenever a WebSocket event occurs. *number, the client ID, an integer, that identifies the connected client. *type, the type of WebSocket event, example type _connected, type _disconnected, type _text, type _bin. Payload, a pointer to the data received from the client, if any. For type _text, this will be the text message. For type _bin, it will be binary data. Length, the length of the payload data. The switch statement handles different WebSocket event types. Type _disconnected, called when a client disconnects. Type _connected, called when a new client connects. It prints the client's IP address and sends a welcome message. Type _text, called when a client sends a text message. It prints the message to the serial monitor and calls handle WebSocket message, to process the message. Type _bin, called when a client sends binary data. Includes a commented out hex dump function that is useful for debugging raw binary data. Type _ping, type _pong, handle ping/pong messages, used for keeping the connection alive. The WebSocket server library automatically handles pong responses to pings, so you don't need to do anything in these cases, but you can log them for debugging if you wish. 9 Send sensor data, function *. Calls construct JSON, to create a JSON string containing the sensor data. *websocket.broadcast.txt, JSON string, sends the JSON string to all connected clients. Use websocket.sendTxt, number, JSON string, to send to only a specific client, number being the client ID. * prints the JSON string to the serial monitor for debugging. 10. Handle WebSocket message, function *. This function is responsible for processing incoming messages from the client. It converts the payload, which is a uint8_t*, to a string. It uses the Arduino JSON library to parse the JSON message. Static JSON document is used for fixed-size JSON documents. The 200 is the capacity of the document, in bytes. Choose an appropriate size based on the complexity of your JSON. If you expect larger JSON documents, use a larger value, example 512 or 1024. Crucially, if the document is too small, parsing will fail. Deserialize JSON, doc, message, parses the JSON string into the doc object. The code then checks if the JSON contains a command field. If it does, it extracts the command and performs actions based on the command, example turning an LED on or off. Adapt this part to handle the commands you want to support from your clients. Error handling. Deserialize JSON can return an error if the JSON is invalid. It's important to check for errors and print them to the serial monitor for debugging. 11. Construct JSON, function *. This function creates a JSON string from the temperature and humidity values. It uses Arduino JSON to create a JSON document and add the temperature and humidity values as key value pairs. Serialize JSON, doc, JSON string, converts the JSON document to a string. It returns the JSON string. 12. Hex dump, function, optional. This function is useful for debugging binary data. It prints the contents of a memory buffer in hexadecimal format. Client-side code, example, HTML/JavaScript. This is a simple HTML/JavaScript example to connect to the WebSocket server in a web browser. Create an index.html file. Client-side code explanation *HTML structure sets up a simple HTML page with a heading, an output div to display messages, and two buttons to send let_on and let_off commands. JavaScript const WebSocket equals new WebSocket, ws/your_ESP32_IP_address81/ creates a WebSocket object, connecting to your ESP32's IP address on port 81. Replace your _ESP32_IP_ address with the actual IP address of your ESP32, printed to the serial monitor. WebSocket.open, called when the WebSocket connection is successfully opened. WebSocket.onMessage, called when the client receives a message from the server. It displays the received data in the output div. WebSocket.onClose, called when the WebSocket connection is closed. WebSocket.onError, called if there's an error with the WebSocket connection. LetOn Add Event Listener, click, and LetOff Add Event Listener, click. These event listeners are attached to the LED on and LED off buttons. When clicked, they create a JSON object with the appropriate command and send it to the server using WebSocket.send, JSON.stringify, command. JSON.stringify is essential to convert the JavaScript object into a JSON string. Steps to run the example. 1. Upload the ESP32 code ***. Open the Arduino IDE. ** Copy and paste the ESP32 server code into the IDE. ** Replace your _Wi-Fi _SSID and your _Wi-Fi password with your Wi-Fi credentials. ** Go to Tools dashboard and select your ESP32 board, example ESP32 Dev module. * Go to Tools dashboard and select the COM port that your ESP32 is connected to. * Click the Upload button to upload the code to your ESP32. 2. Open the serial monitor ***. After the code is uploaded, open the serial monitor, Tools-Serial Monitor. Set the baud rate to 115,200. The ESP32 will connect to Wi-Fi and print its IP address to the serial monitor. Note this IP address, as you'll need it in the client-side code. 3. Open the HTML file in a web browser ***. Save the index.html file. Open the index.html file in your web browser. Important replace your _ESP32 IP address in the JavaScript code with the IP address you noted from the serial monitor. Don't forget to save the HTML file after making the change. 4. Test the connection ***. The web browser should connect to the ESP32 WebSocket server. You should see connected to WebSocket server in the browser's output area. The ESP32 serial monitor will show that a client has connected. The ESP32 will send sensor data to the client every 5 seconds, which will be displayed in the browser's output area. Click the LED on and LED off buttons to send commands to the ESP32. If you have an LED connected to GPIO2, it should turn on and off. The serial monitor will also print the received commands. Important considerations and enhancements. Error handling. Add more robust error handling in the handle WebSocket message function, especially when parsing JSON. Check for missing fields, invalid data types, etc. JSON size. The static JSON document size is crucial. If your JSON data is larger than the allocated size, parsing will fail. Monitor the error messages and increase the size if necessary. Alternatively, consider using dynamic JSON document, but be mindful of memory fragmentation. Multiple clients. The WebSocket server library handles multiple clients automatically. The number argument in the WebSocket event function identifies each client. Use this to send messages to specific clients, example websocket.sendTxt, number, message. The broadcast.txt function sends to all connected clients. Security. For production environments, consider using secure WebSockets, WSS, with SSL/TLS encryption. This requires setting up certificates and using the Wi-Fi client secure library. Web server. If you want to serve the HTML file directly from the ESP32, you can use the web server library. This eliminates the need to open the HTML file from your computer's file system. Look into using SPIFs or fs to store the HTML file on the ESP32's flash memory. I added a commented outline web server 80 in the code to show how you would initialize the web server if you wanted to add it. Real-world sensors. Replace the simulated sensor data with actual sensor readings from your sensors. Asynchronous operations. For more complex applications, consider using asynchronous programming techniques, Example free RTOS tasks, to handle WebSocket events and sensor readings concurrently. This prevents blocking the loop function. WebSockets client libraries. There are many WebSocket client libraries available for different programming languages, example JavaScript, Python, Java. Choose a library that's appropriate for your client application. Memory management. On embedded systems like the ESP32, memory is limited. Be mindful of memory usage, especially when dealing with strings and JSON. Use static JSON document whenever possible, and avoid unnecessary string copies. HTML serving and WebSockets from the same ESP32 if you plan to have the ESP32 serve the HTML page and also run the WebSocket server, you'll need to integrate the web server with the WebSockets server. Here's a basic example. Key changes. Includes webserver.h. Creates a web server object on port 80, the default HTTP port. Defines HTML content to hold the HTML to be served. You can load this from a file using spiff/fs for more complex pages. Handle root, function sends the HTML content when the root URL, / is requested. Server.on, / handle root, registers the handle root, function to handle requests to the root URL. Server.begin, starts the web server. Server.handle client, must be called in the loop, function to process incoming HTTP requests. The HTML content now tells the user to connect to port 81 for WebSockets. With this code, you can access the HTML page by going to http://esp32_ip in your browser. The WebSocket connection will still be on ws//esp32_ip81. This comprehensive tutorial provides a solid foundation for building ESP32 WebSocket servers with JSON communication. Remember to adapt the code to your specific needs and experiment with the various features and options available in the libraries. Good luck.